Hey everyone, welcome to my quest of making every single tiny device or embedded component I got from AliExpress working in Rust. This time I'm looking at a digital temperature and humidity sensor. This is an AHT10. Apparently it was really inexpensive. I got a couple and I figured, okay, let's make them work. So let's see what we need to make them connect. I connected everything as in my previous tutorial for a display with I2C, so I will go reasonably fast in typing in everything. Actually, I will copy and paste all the settings to set up the I2C. I will explain a little bit what I'm doing, but basically I do not want the LED. I will just say in advance AHT initialize at some point, but for now let's do empty. So in here let's remove unused imports, and I will add HAL I2C. Delay I will need later. Maybe I will do underscore delay for now. Let me go through the code. Okay, fine, I'm not using I2C yet. So basically what I'm saying, I connected everything to PB6 and 7 because I know this is clock and this is data line. So what I'm saying, I want to access the peripherals, and I create an I2C component that will use these peripherals. I am putting it at 100 kilohertz. I think the device supports up to 400 for high speed, but this should be good enough. So I have an I2C, and this is where things get different from the display. So I will go slightly slower and I will explain what I am doing. First of all, let's go in here, and if I would search for AHT10 on docs.rs, it brings me to this driver. Also, I can do a cargo search, AHT10, and it will tell me there's a version. I checked GitHub, it's 3 years old, but well, it looks like a fairly clean interface. If I click on the driver, what it tells me is that I just have to create a new one. I have to give it a delay, and then I can read and reset and do all I want, which looks awesome. And actually it was short enough that I thought the video may not even be needed, but in the end there is some debugging involved, so that hopefully this is interesting. Another new thing here, like I will try to do some error handling, meaning most of these things return results. So in this case, for example, I will say I want create a new AHT10. If I look at the documentation, this returns a result. So I will want to see if the result gives an error. I will want to print out error. Apparently I managed to compile this out. Let me compile it back in. So what I do is I create a new AHT10 I2C, and I create a clone of the delay because in my loop eventually I want to do something like delay, let's say 100 U16. So the idea would be that I want to print the current temperature, print the temperature, and then wait a bit and then print the temperature again. So that would be my idea. So if I have some I2C error, all the errors support debug printing. If I don't do debug printing, it will say, no, this is not good. So I put question mark, and I have to say delay right now is actually used. And I will need to start using this AHT10 again. So I'll go to Cargotomel. I don't care about the version. I know it's 0.0.1, but that's fine. And in main.rs, I did some debugging, hence other files. I'll go through that later. So let's say here, I will use AHT10. And it tells me a bit. Fine. I fully spec the path, and it will tell me it's not used, but I will use it soon. So now I have a valid AHT10 that is initialized. So what I would like to do is to start using it, and the way I will use it inside my loop. So for me, I want to read the values, and if the values are okay, then I would like to display them. I don't want to display the raw values. I think I have them in an example, but they are not as interesting. So the way the interface works is fairly simple. Like you can create new, you can also reset it if you want. You can read the actual value and you can show the temperature. Temperatures can be in Celsius, and humidity, RH is relative humidity. The way I got these values are, I have new that returns an I2C, and then it asks me when I read, it returns a tuple of humidity and temperature, and if I click on one of them, it tells me what they are. So temperature, it says, well, you have a way of getting Celsius, that's a float number, and for the humidity, you will have the exact same thing. It will say you have relative humidity and also the raw values if you want. So right now, this was extremely short. Like I create an AHT10, I can unwrap it if I didn't have an error, and then I can keep reading it. So I will cargo run release. Amazingly enough, I don't do release. I still run out of flash. I don't know why it's so big. But I get hit with this, which I found, well, this is actually annoying. It seems like it's totally uninitialized. So now let's go through how in the world am I debugging this. So the way I did it is I have this AHT10, and I know that it's somewhere in GitHub. Whoops, misclicked. So I would say git hub AHT10, and I did not say Rust. So let's say this is the driver that is actually being used. It hasn't been updated in a while, but I actually did send a pull request to fix it, and it gives all the examples of how to use it, which is awesome. We use a different delay because I'm a CortexM0. I don't use Linux embedded HAL, and reads. So the thing is, what I want is to debug this driver. So if I look at the code, it will tell me how do I clone it. You can clone it through HTTPS, SSH. I will do repo clone. So let me go to this other console, and I cloned the repo. And if I look at the path, this is the path where I cloned it. And this is where things get interesting. So I'll go to Cargotomel and I will say AHT10 is not what anything. Let me use the local path so I can actually debug things. I have AHT10, and now if I compile, it will use the local path. So one thing that I can say is I will say add project to add folder to project, and I will add AHT10 so I can take a look of what is inside. Ideally, I would like to debug it. So the same like I have in main.rs here, I have rprintln. I would like to go in here and say rprintln. And somewhere in the creation, let's see, when I create, I will say print creating, and it will underline it saying that I don't know what rprintln is because I don't have the actual crate used. So I will copy the RTT target crate into Cargotomel, and because I'm developing it, well, I'll put it everywhere, but realistically this should work. Now I saved it. And it complains that it doesn't know what RTT target, maybe missing crate. Well, maybe. I have to use extern RTT target. Does this make the compiler happy? Sure, it does. Excellent. So I'll cargo run release. And I can see the values, but it's no further information. So the next step that I would like to do is figure out, is there a driver that actually works? I can try to read the datasheet, but I couldn't find a good datasheet for this device. And based on the comments in this driver, it seems that some documentation is definitely missing. Like in this case, the author said sort of reverse engineering, it gives all sorts of data. So in the end, what I figured, let me get a driver that actually works. and see if I can find things there. So in this case, I knew that Adafruit is selling this device and has a Raspberry Pi driver. So let's take a look at what Adafruit does. So I'm looking, it's a header and CPP file. Excellent. And when I look inside, I will see that it has all sorts of commands, including calibrate, trigger. It has some statuses of busy and calibrated. When I go into the code, the Rust code that is, I will see the same things, formatted a bit different, but I checked and they are generally the same. Like the calibrated is calibration enabled, busy is the right flag, the commands are correct. So what I need to do is figure out what Adafruit does differently. And I will go first when things get created. When the Rust code creates, first of all, it does a get raw and it delays for 300 milliseconds. Then it does a calibration with this flag, which is hard-coded. Oh well, I'll see what Adafruit does, and then it delays some more. I'll switch back to the Adafruit driver and let's see what they do. It's probably in the CPP file. And creation. First of all, it does a soft reset. So this means it doesn't do a read, it does a reset, which is interesting. And then it sends a calibration. Notice it's the same hard-coded value. It's on 2 bytes, like 0800, but still it's the same like the Rust code does. And then I see a loop of trying to get the status, and it waits for the status to not be busy. And once the status is not busy, it checks whether it's calibrated. And if it's calibrated, it says, I am done. So let's try to adapt the code to do the same thing. So let's say, first of all, I want to send a reset. I don't want to send a read. And then I would like to implement this loop of getting a status. Let's see how that can be done. So command get raw. I think there's command reset. Yeah, we have reset. So let's not use get raw. Let's use reset. And I think Adafruit is sleeping for only 20 milliseconds. So let's do that. I mean, faster operation is faster. And then it writes calibrate with 3 bytes. Perfect. And it sleeps how long? It does not sleep. It does not sleep, however, it wants to get status. How do I get the status? So getting the status is just a read. Interesting. So I will implement this. So let's say get read status. And I will do a result. And what's the result? Well, it's something and an error. And if I look at that something, I probably want some status flags because I'm reading a status. So let's say I want the result of status flags and the error E. And let's see how read is being done. So I see here that this is write read when we do value and we do write. And unfortunately, these are only 2 things that the interface supports right now. The reason being that when I create the interface, in here it says the I2C interface should support write, read, write, and nothing else. But I need to only be able to read. So I will say, let's support the read as well. And I will go on top and say write, read, and I'll also need read. Excellent. So now I have read status. So I'll have to read, and I actually don't know how to read. I will copy and paste this thing. It's easier. And I only need 1 byte, as I understand from Adafruit example. And I don't write, I just read. And from the I2C address, I only read from the buffer. This is short, there's no reverse engineering. And then I will need to return an OK. The first thing I want to write is to see that I actually get some value. So I'll use the macro that I just created. And we succeeded. So OK of status. This is good enough. And let's go in here. We wrote a calibrate. We shouldn't be waiting as long, or we don't wait at all, actually. I'll keep the notes, and let's loop. So I'm reading the status, and if there's an error, I should return error. And now if I have the status flags busy, I think Adafruit just continues with some sort of a delay. Let's see the delay. 10 milliseconds. Okay. Delay. Otherwise, another option would be if it contains calibration. There is no calibration, so in this case I would want to return an error. Uncalibrated. This will actually fail because the return code here, it says E, not error of E. So what I will tell it, the result is an error. If otherwise, break, because we have finished the loop and the device is initialized. So this is fair. So I did the init. Now I'm wondering, how about the read? The way this read works, it assumes that it will succeed in one go. So let's see what Adafruit code does. I'm using get event. I don't because it uses the same command trigger. I check the values. The first thing I see, it writes 0x330. Then it keeps reading status, and if status is successful, it will read 6 bytes. This is totally unscientific, but I'm looking at here, and this doesn't write 33, it writes FF. So let's adjust that. I have no idea what they do, so I'll delete the comment, but this is probably wrong. Also, I don't think I need to write and read, because I just write, and then I will keep a loop to read the values. So let's just write and leave the status alone. I know already how to make a loop of getting the status, so I'll copy it from here. Probably this could be refactored to be somewhere else. So let's see if I do the same thing. So if I write while I'm busy, just delay, and actually it doesn't check for calibrated. That's interesting, because previous code was checking for calibration. I'll leave it alone. I assume it should be there. And then the other thing it does, I think it only reads 6 bytes, not 7. And it doesn't know what dev is because I copied and pasted. Now let's see what happens if I run. Well, it tells me quite a bit of busy, and it says like busy, 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 and then calibration is enabled. Now, what I will look like, I was actually expecting this to work, interestingly enough. I will have to check what I did differently in my patch to Anthony, because I believe in that case, I actually made it work. So well, this is embarrassing. So apparently what I forgot to actually read. So I created this buffer. I never read from the buffer, and obviously that doesn't work. So let's read. I2C address, buffer, and question mark. So I'm reading. Let's run it. And you can see that the temperature and humidity seem to actually work. A quick way for me to test it is I see a temperature as 25 degrees. And well, first of all, the read status is annoying. So let's remove some debugging from this library. I don't want it to be so busy. Let's run it again. So anyway, the temperature is 25 point something degrees. What I expect, if I put my finger on it, my finger is warmer. So let's see it move up in value. So you can see it keeps increasing, 27, probably eventually 28. And now I remove my finger and it should somewhat drop down. So I can see it goes 27 and keeps going down. So that was it. I hope this was interesting. So in summary, what it shows this is how you create a local path, and this is how you patch local sources, local libraries, local crates, and make them work for you. Thank you, and have a great day.